Good morning, class. We are looking at section 1.6, sequences and difference equations. As it was mentioned, you can find this PowerPoint under the modules of Canvas, exam 1 module. You don't have to write any definition or proof, just a solution to examples. 1.6, sequences and difference equations summary. A sequence is a list of numbers written in a specific order, a sub 1, a sub 2, all the way to a sub n. First, second, nth terms of the sequence. A sub n is the general term, and n is the set of positive integers 1, 2, 3 to infinity. Recursive sequence, also known as difference equation. A recursion or recursive formula defines a sequence by specifying the first few terms of the sequence and using a formula to specify subsequent terms in terms of preceding terms. The next term depends on knowing the previous one or previous ones. And the format is a sub n plus 1 is f of a sub n. Arithmetic and geometric sequences, you should be familiar with them. An arithmetic sequence is in this form: a sub 1, a sub 1 plus d, a sub 1 plus 2d, and a sub 1 plus n minus 1 times d, where the difference d between consecutive terms is constant, can be defined by recursively a sub n plus 1 is a sub n plus d. This is a common difference or distance, d. Or explicitly by a sub n equals a sub 1 plus n minus 1 times d. Example 1, 5, 9, 13. As you can see, we are adding a common number of a 4. Similarly, a geometric sequence, a sub 1 times r, a sub 1 r squared, and a sub 1 r to the power of n minus 1, where each term is r times the previous one, can be defined recursively by a sub n plus 1 is r times a sub n. In other words, pick any term, multiplied by r, you get the next one. Or explicitly, a sub n equals a sub 1 r to the power of n minus 1. So 1 times 4 is 4. 4 times 4 is 16. 16 times 4 is 64. So we are dealing with r being 4. We are multiplying by 4 to get to the next one. Sequences. A sequence is a list of numbers written in a specific order, measurements collected at discrete time points, and quantities that undergo periodic changes, such as annual plant or insect populations, are studied using the concept of sequences, the data and difference equation, the description of the mechanism of change. A sequence is a real valued function f, whose domain is the set of natural numbers 1, 2, 3 to infinity. We use the notation a sub n to denote f of n. So a sub 1, a sub 2, all the way to a sub n. A sub 1 is the first term, a sub 2 is the second term, and a sub n is the general term. Given the general term, find the first 5 terms. Well, obviously, a sub n equals to n. That means a sub 1 is 1. The first one is 1. The second one, a sub 2 is 2. And therefore, the first 5 terms are simply 1, 2, 3, 4, 5. That's very simple. This one lets b sub n is sine of n pi over 2. Replace the n with 1. All the way to 5. So pi over 2, 2 pi over 2 or pi, 3 pi over 2, 4 pi over 2 or 2 pi, 5 pi over 2. Now I want to remind you of something that we have seen previously. In algebra, the equation of a circle is x squared plus y squared equals r squared if it's centered at 0, 0 with the radius r. If it's centered at h and k, it's x minus h quantity squared plus y minus k quantity squared equals r squared. I hope you remember that. And actually, the formula comes from the distance formula. When the radius is 1, in this case, we call it a unit circle. So x squared plus y squared equals 1, r is 1. So if that is the case, we have this point at 1, 0, this one at 0, 1, negative 1, 0, 0, negative 1. We also have this one having an angle that makes with the positive side 0, 90 degrees or pi over 2, 180 degrees or pi, 270 degrees or 3 pi over 2, and goes back to 0 or 360 degrees. Now, in the case of a unit circle, the definition is x represents cosine t and y represents sine t. And so with that being the case, over here we can see that cosine of 0, remember x is 1, and sine of 0 is 0. So look at this pair. Remember that this pair was located at 1, 0. So this represents cosine 0 and then sine 0. And again, let me just write this. This was 1. This was 0. Which means cosine of 0 is 1. Sine of 0 is 0. Now when we look at this one, I'm going to write it here. Cosine of pi over 2 or 90 degrees is 0, the x coordinate. Sine of pi over 2 or 90 degrees is 1. This one has coordinates negative 1, 0. That means cosine of pi or 180 degrees is negative 1. Sine is 0. This one, remember, has coordinates 0, negative 1. That means cosine of 270 degrees or 3 pi over 2 is 0. Sine of 3 pi over 2 or 270 degrees is negative 1. The reason I went over this because this makes it easy to memorize the answer to the question here. So sine of pi over 2, this is positive 1, 0, negative 1, 0, positive 1. Again, understanding the concept. This was a piece of information from basic trigonometry. All right, we are going to move on, and to do that, I need to clean up here. C sub n by definition is n over 1 plus n. So if I want C sub 1, I replace the n with 1. I get 1 here, 1 plus 1 here, right? So I get 1/2. What if I want C sub 2? If I want C sub 2, I put 2 here, I put 1 plus 2 here. I get 2/3, and you can figure out the rest on your own. D sub n is the digit in the nth decimal place of pi. I hope you know pi is not 3.14. Pi is approximated by 3.14, and it's 3.14159, and it continues indefinitely. So the very first place is 1. So D sub 1 is 1. D sub 2 is 4. D sub 3 is 1. D sub 4 is 5, and so on. So 14159. That's what the question is asking. Given the general term, find the first 5 terms of the sequence A7 is 2 to the power of n minus 4. We start with number 1. So what is A sub 1? We put 2 to the power of 1 minus 4. And that's negative 2. What is A sub 2? Replace this one with 2, replace this one with 2. You get 2 squared, 4 minus 4 is 0. If you can do 2, you can do more. If I want number 3, 2 cubed, 8 minus 4 is 4. And the rest of it. And these are the 5 terms. Negative 2, 0, 4, 12, 28. Again, you have all these questions, class. We are going over the solution. Find the formula for the general term of A sub n if this is 5, 8, 11, 14, and 17. Notice that we are adding a constant. This is an arithmetic sequence. What are we adding? Number 3. So it's arithmetic sequence with the difference or distance of 3. So A sub 1, the first term is 5, and these 3, because look at this one, you add 3. Same thing here. And you really have to check quite a few. You can't just assume the first one and that's it. So we have A sub 1 and we have the D. And we recall A sub n is A sub 1 plus D times n minus 1. So replace A sub 1 with 5, D with 3. Five plus 3 n minus 3, and these two combine into plus 2. For part B, we notice it's a geometric sequence with the ratio of negative 1/3. In other words, If you multiply this one by negative 1/3, you get negative 1/3. You multiply by negative 1/3, again, you get 1/9. You multiply by negative 1/3 is negative 1/27. So you have a geometric sequence where a sub 1 is 1 and r is negative 1/3. So here's the first term, and here's the ratio, constant ratio. So a sub n is a sub 1 r to the power of n minus 1. So you put 1 here, negative 1/3 here, and you do the math. So this is following the formula. When we have an alternating sequence, it is really a better idea to separate the sign. So this negative 1 has to be separated. That's why negative 1 to the power of n minus 1, and then 1/3 to the power of n minus 1. This one has no bearing. For alternating sign, we either get negative 1 to the power of n or negative 1 to the power of n minus 1. I want you to see which one and why. If you go with this one, when n is 1, negative 1 to the power of 1 is negative 1, but the first term is positive, so that doesn't work. This one, negative 1 to the power of 1 minus 1 is 0, negative 1 to the power of 0 makes it positive, so that works. By the way, instead of n minus 1, if you wrote n plus 1, it works the same way. Recall that a to the power of 0 is 1. Negative 1 to the power of n minus 1, 1/3 to the power of n minus 1. Negative 1 to the power of 0, 1/3 to the power of 0 is 1. So the very first one is 1. It's important to see that. And the sign is positive. All right, difference equations. Sequences are sometimes created recursively, specifying the next term given the present term. The initial term of the sequence must also be specified. This procedure defines each new term as a function of the previous one, and it may not always be possible to determine the general term of a sequence algebraically. A difference equation, also known as recursive sequence, is an equation of the form a sub n plus 1 is f of a sub n, where a sub 1 is given and f is a real valued function. A solution is a sequence a sub 1, a sub 2, all the way to a sub n, satisfying the given difference equation. For example, the Fibonacci sequence, you may remember it from algebra. The first term is 1, the second term is 1, and any other term is the sum of the previous two when n is larger than or equal to 3. For example, 1 and 1, they add up to 2. 1 and 2, 3, 2 and 3, 5, 3 and 5, 8, 5 and 8, 13, 8 and 13, 21. What would be the next one? You add these two, you get 34. Okay, the next one would be 34. Add them up. Example in nature, the number of branches increases up a tree trunk according to the Fibonacci sequence. We start with 1, continues with another one the next year, and then the following year is the sum of these two, and then you add these two, you get 3, you add these two, you get 5 branches, so on and so forth. Let's look at this example. We want to find the first 6 terms of the recursive sequence, where a sub 1 is given as 6, and a general term, a sub n plus 1 is a sub n divided by n, meaning if you want a term, go to the previous one, divide by n. So a sub 1 is 6. If I want a sub 2, I want a sub 1 divided by 1. I hope you recognize how we do that. Just for the sake of argument, make this one 2, n plus 1 is 2, so n becomes 1. So this becomes a sub 1 over 1, okay? I want the next one, I want a sub 3. So I need the previous one, which is a sub 2 divided by 2. A sub 3 is a sub 2 divided by 2, which means 6 divided by 2 is 3. Let me do one more, a sub 4. If I want a sub 4, I go to the previous one, a sub 3, and divide by 3, which makes it 3 divided by 3, right? This is a sub 3, which makes it 1. And I'm going to assume you can figure out the rest. I leave them for you to figure them out. And so we write the first 6 terms, 6, 6, 3, 1, 1/4, 1 over 2. Part B, a sub 1 is 1. A sub 2 is 2. A sub n plus 2 is a sub n, and a sub n plus 1 plus 2 a sub n. In other words, if you want a term, any term, go to the previous one, and then 2 times the one even before that. So I want a sub 3 because I have a sub 1 and a sub 2. If I want a sub 3, I want the previous one, a sub 2, and then 2 times the one before that, 2 times a sub 1. One way to look at this class, just to make sure you can handle this, you can say this is 3. So if n plus 2 is 3, n is 1. So replace this one with 1, replace this one with, it's that simple. So a sub 2 is 2, 2 times a sub 1 is 2 times 1, they add up to 4. So I want a sub 4. I go to the previous one, a sub 3, and 2 times the one before that, a sub 2. In other words, I write the general formula. I want this to be 4. N plus 2 is 4, so n is 2. 2 and 1 is 3, and this is 2. Let's recap. I want to make sure we understand this. I want a sub 4. I go to the previous one according to this. The one before that is a sub 3. And then the one before that is a sub 2 times 2. Or say this one is this one 4. If n plus 2 is 4, n must be 2. So if you replace this with 2, 2 and 1 becomes 3. And this is 2. So a sub 3, which makes it 4, plus 2 times a sub 2, which makes it 2. 4 plus 2 times 2, it's 8. A sub 5 Okay, according to this formula or this formula, I want a sub 5. I want the previous one, a sub 4, plus 2 times the one before that, a sub 3. So a sub 5 is the previous one, plus 2 times the one before that. Or just like I said, n plus 2 is 5, n becomes 3. This is 3, this is 4. So a sub 4 is 8, 2 times a sub 3, 4. 8 and 8 is 16. And I'm going to leave it for you to figure out a sub 6. And these are the answers. All right, a sub n plus 1 is 2, a sub n minus 4, a sub 1 is 3. So if I want a sub 2, I want 2 times the previous one, 2 times a sub 1 minus 4. So I want 2 times 3 minus 4, which makes it. So I want a sub 3. If this is 3, this is 2. 2a sub 2 minus 4. So again, you want a term 2 times the previous one. I want a sub 3 2 times the previous one. So 2 times 2 makes it 4, minus 4 is 0. Definitely, I'm going to leave this for you to finish it off. So I have calculated. I've given a sub 1, I've calculated a sub 2, I've calculated a sub 3, and then the rest of the minus 4, minus 12, minus 28. I highly recommend you do that on your own to make sure you can figure this out. Example 5, suppose C sub t is the concentration of a drug in the bloodstream at time t. A is the inflow, is the concentration of the drug that is administered at each time step. And K is the fraction of the drug metabolized or absorbed in a time step. What is the recursion that models the dynamics of drug concentration? So please understand, when we are dealing with medications and patients, when we give them the medication, a portion of it is absorbed. That's the idea. N sub t plus 1 is n sub t plus inflow minus outflow. So that means the next step is the amount that we give in the previous step, okay, plus what comes in minus what goes out. So because we want to go with C, we're going to write the C sub t plus 1 is C sub t plus inflow. We're going to go with A. Inflow, we're going to go with A. And outflow, K is the fraction of the drug that is absorbed. So K at times the beginning C sub t is gone. So I want to make sure we understand this formula. C sub t plus 1 is C sub t plus what comes in minus what goes out. What goes out, this is a fraction of the drug. So for example, let's say 70% is gone, so 0.7 times C sub t is gone. 80% is gone, 0.8 times that is gone, okay? That's the idea. If you combine these two, you can factor the C sub t out and you get 1 minus K. And it's important to understand the meaning of this. the meaning of this C sub t times 1 minus k, k is the portion that leaves the body, is absorbed. What is left? 1 minus that. For example, if 80% is absorbed, 20%, 1 minus that, is left in the body. That's the idea. If the initial concentration is C sub 0 equals 120 microgram per milliliters, and A equals 80 micrograms per milliliter, and K equals 1/2, plot some points on the graph of C sub t. Well, let's see what's given, and we're going to put it into the formula first and foremost. It's a C sub 0. The initial amount is 120 microgram per milliliters. Then the amount of inflow, A is 80, K is 1/2, that's the given. And into this formula, C sub t plus 1 is C sub t 1 minus k. K goes k, which is 1/2, and goes A, which is 80. It so happened, because it's 1/2, 1 minus 1/2 also gives you 1/2. So we don't want to be, mixed up. So this is half. Okay. So half of C sub t plus 80. That's the general formula. And what it means is that if you want to know what happens in the next step, find half of the previous step and add 80 to it. That's the meaning of it. Why half? Because half is absorbed, half is left. And so remember, this is C sub 0. By the way, when it comes to patients, normally C sub 0 is 0. I want you to know that. Now, what is C sub 1? So according to this formula, C sub 1 is half of C sub 0 plus 80. Again, C sub, if you set this equal to 1, t becomes 0. So half of C sub 0 plus 80. So half of 120, which is 60 plus 80, makes it 140. Let's do one more. C sub 2, according to this formula, if I want C sub 2 is half of C sub 1 plus 80, half of the previous one. And C sub 1, over here we have 140. So half of that, which is 70 plus 80, makes it 150. Can anybody tell me what is C sub 3? What would be the amount for C sub 3? Anyone? According to this general formula. Well, C sub 3 is half of C sub 2. That means half of this. 75 plus 80, 155. Half of t C sub 2 plus 80. And as t gets larger, C sub t becomes A over K in general. It looks like this, and it levels off. So the amount of inflow, which is 80, divided by K, K was 1/2. So 80 divided by 1/2, that means 80 times 2, that means 160. So here's C sub n is A over K, 80 divided by 1/2, 160. What does it mean? It means if you give medication to a patient, according to this, and there is a time step. Time step is the amount of time it, passes before you give the next medication. Because a portion is absorbed, at most, it will never go beyond 160 what? Micrograms per milliliter of medication. As far as the proof, this is the formula. Assume the limit exists. We're going to take a limit of this one. And that is the proof. You don't have to worry about this proof until we get to it next time. But just to give you an idea, c sub t plus 1 is c sub t times 1 minus k plus a. You have it here. Okay. So if the limit exists, the limit of the left and right are the same. The limit of this one and this one are the same, and it's L. And if you take the limit of the right side, you get L times 1 minus k plus a. If you solve that, you get L equals a over k.